Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Badrul Amin bin Razak and I am from Group 2, Section 2. My metric number is MA19082. Okay, today I will present about Engineering Fluid Mechanics Labs, Pelted Wheel Turbine. So, for introduction, background, Pelted turbine is a hydraulic turbine that has a bucket on a wheel. Like this, pellet turbines are usually used uh, on dams to produce electricity. The force generated by the jet strike at right angles to the buckets produce torque, which causes the wheels to turn and resulting in power. The term Pelton derived from an American engineer who investigated the perfect design for the turbine buckets. This is figure 1, shows the Pelton turbines that have three main parts, which is a stationary inlet nozzle, a runner, and a casing. Okay. Multiple buckets are mounted on a spinning wheel to make up the runner. When the jet hits the buckets, it creates momentum. The buckets are designed in such a way that the flow is divided in half, and the relative velocity vector is practically turned 180 degrees. The power produced as the jet is diverted by spinning buckets in the primary features of the impulse turbine. Assuming the outgoing jet speed is zero, a few of a jet's potential energy is wasted pushing the buckets. There are minor losses at the nozzle and at collision with the bucket, assuming that entire available heat is converted into jet velocity. Due to gravity, water goes via a spear valve, this is a spear valve, that will manage and operate the incoming flow through a nozzle onto the buckets. Okay, we go to problem statement. The specification of a Pelton turbine are controlled by altering the rotational speed with constant pressure and constant volume flow rate to modify the energy output, input, and system effectiveness at the outlet. Okay, objective to evaluate the Pelton turbine under various loads and speed valve settings, and to generate graph that depicts the turbine efficiency and the impact of various speed valve setups. And scope: the purpose of the experiment is to investigate the specifics and performing metric of the Pelton turbine, such as its power, productivity, and manufacturing. I think that's all from me.
Assalamualaikum and good day everyone. My name is Wana Adiba, MA19080, and I would like to resume our presentation with the theory for our Pelton wheel experiment. So I will start with the definition of water turbine, which is a water turbine is used to transform heat energy into mechanical work. Based on how the energy in the revolving blades is transformed into motion, turbines categorized as reaction or impulse. So, a change in fluid volume in blade channels causes an increase or reduction in pressure. An impulse turbine converts the water heat into a high-velocity jet, which then strikes the bucket at a single location. The runners have a few vacant areas, and the jet flow through the buckets is constant pressure. Also, impulse turbines are well suited to high-paid, low-power applications. So in this experiment, the impulse turbine and Pelton turbine was used. So we move to the impulse and reaction turbine. So the main difference between impulse and reaction turbines is that the impulse turbine converts all hydraulic energy into kinetic energy via a nozzle, whereas the reaction turbine only converts a fraction of the available energy into kinetic energy. The differences between the two types of turbines are depicted in uh, in the table here. So we go one by one. So in uh, differentiation between impulse turbine and reaction turbine for energy is for impulse turbine, a nozzle will transform all hydraulic energy into kinetic energy, while the reaction turbine only a small portion of the energy is transformed to kinetic energy. For the water discharge needed description for impulse turbine and reaction turbine, so impulse turbine have low water discharge need and A reaction turbine have medium and high water discharge. Also, impulse turbine is in a tangential direction, while the reaction turbine may be approached from both the radial and axial direction. Also, for efficiency for impulse turbine have more hydraulic efficiency, uh, while reaction turbine has less efficiency. For the water head, impulse turbine have high water head compared to the reaction turbine, which has medium and low water head. For example, for impulse turbine, we use Pelton turbine. For reaction turbine, we use Francis and Kaplan turbine. So last but not least, we go through to the Pelton turbine, which is the Pelton turbine is an example of an impulse turbine. So a water jet of a several water jet impact buckets on a turbine wheel, forcing it to spin. The impact of the water jet provides a force parallel to the buckets, which cause the top to turn the wheel, while a result, the wheel creates energy as it turns. With a turbine like this, more electricity might be created. So a turbine with an impulse generator that gets its energy from a reaction turbine, all of the hydraulic energy is converted into kinetic energy by a nozzle. So only a small percentage of total energy will be converted to kinetic energy in this manner. So Pelton wheel turbine should be half the speed of the water jet for best efficiency. According to theory, the bucket speed of a Pelton wheel turbine should be half the speed of the water jet for best efficiency and the best for lot of headroom but a low for flow rate. So that's all from me for theory, and I will pass it to the next presenter for the next topic. Thank you.
Assalamualaikum and a very good day. So my name is Nil Rashki binti Rajadullah, MA 19107. So for this lab, I am going to present the apparatus and procedure of the lab. So these are the apparatus needed for this lab, which are we need the Pelton turbine and also the hydraulic bench. As in the picture, you can see the every parts of the Pelton turbine and also the hydraulic bench for us to undergo this experiment more easier. Next, I will explain the procedure of this lab. The first one is the two drain valves on the releasing basin to the closed location are turned on. On the inlet pipe, discharge to control valves was released and the pressure was recorded. Top gas set to 0 and top control will loose up to free the turbine shaft or friction. By using the point gauge on the basin, the head of the well was observed after the water level in the basin settled. Make sure the tacho reading line is perpendicular to the shaft phosphorescent tape. By using the given tachometer also, the rotational speed of the shaft is calculated when there is no torque resistance on the shaft. The friction hand wheels were tightened slightly and the tachometer was used to monitor the torque shown on the friction gauge and the shaft rotational speed. Step 3 until 6 were repeated until approximately 10 different settings were obtained with the last set with the turbine stop. Torque brakes are completely loose and the friction gauge was set to 0. Lastly, the basin is drained until just a trickle of water flows over the well by opening the drain valve for the basin to drain. That's all. I'll pass to the next member. Thank you.
Hi, my name is Rosnila binti Ramli and my ID is MA1901. So today I will present the result and discussion for Pelton turbine experiment. So for the result, so table 1 show that we have to evaluate the Pelton turbine wheel load. So which is we have different load 1 and load 2. So we start with 1.5 for the first value until the last one is 14.25, and followed to at the first value we start with 1.5 and experimental until the last one is we use the same value, which is 1.75. So for the speed we start with 1300 and until the last one is 500. So for pressure we use the same value, which is 1.3. So for the result water collection time we have result 14 point something all the value, but for the first load we got 14.1, and for the second value 14.38. Next one is 14.79, 14.56, 14.53 until the last one is 14.73. So table 2 we have average speed, which is we start with 1300 for the first value until the last one is 500. So for load we start with 0 value until the last one is 12.5. So for average speed we start with we got 136.13. The last one is 52.37. So for the torque, for the first one is we got 0, and the last one is we got 0.325, and output power also we got for the first value at 0, and the next one is we got the value. So for result for table 3, which is pressure, we use same value, which is 1.3. So flow rate we start with 42.53 until the last one is 40.72. And then input power we got 92.21 until the last one is 88.27. And for the output power we got the power at 0 value until the last one is 17.02. So for the efficiency we got the first one is 0, so the next one is we got the value. So after we get the result we can discuss about the first one is theoretically we know that when a load is applied to the wheel via the belt, it's some friction that make the wheel hard to turn. So because of this, the speed of the wheel is reduced. Then when wheel speed decrease, the output power will be prompted and also lose weight. So the next one is we can find that the torque is reverse proportional to the speed. So that means that as speed increase, torque also will be increased. So this is due to the load being directly perpendicular to the well-turned wheel. As we all know that torque is the applied force multiplied with by the vertical line distance. So as the applied loads increase, the torque also will increase. So the friction increase and there are only one to decelerate. So according to this experiment result, we get that the speed that gives the best performance at 800 rpm that produce the highest output, which is 19.06 volt, and the highest efficiency is 21.83%. So in this experiment also we have the maximum power generated by the Pelton wheel, which is 19.06 volt at 8 rpm. So of course in this experiment we have some errors when doing the experiment. So a leaky water meter causes our volume reading to be wrong. So beside that, parallel also occurs when reading water and pressure gauge because the eye level is not perpendicular to the level. So for the next part I will let my friend present it.
Hello, my name is Nur Shafika binti Adira. My ID is MA19094. I will conclude this experiment, Pelton wheel turbine. In conclusion, we can finally demonstrate a Pelton wheel turbine from this experiment. From the experiment, the load applied to the wheel via the belt has some friction that makes the wheel hard to turn. When the wheel speed decreases, the output power will be prompted and also lose weight. We also find that the torque is reversed proportionally to speed. This means that as speed increases, torque also increases. This is due to the load being directly and perpendicular to the Pelton wheel. And lastly, we achieve all the purpose of this experiment. That's all from us. Thank you.